Okay, well, we don't see Schwamigan in the room yet, but we're going to go ahead and get started anyway. So I've got an example up here for you guys to give a shot. Like I said, it's got a little extra twist in it, kind of like when we threw in the units. This time we're throwing in the grains. GR4 means 4 grains. GRIV is 4 grains. So the doctor's orders here are for 4 grains of medication. So that's what we're going to start out with, is that 4 grains over 4 hours. So we're going to create the rate using that. Now, if we wanted to, and I would be tempted to, what I would most likely do here, since that's 4 grains over 4 hours, I would reduce that before I even start and make that just 1 grain per hour. So then from there now, we'll actually start the conversions, the dosage calculations. We are trying to get this into drops per minute. So we have to get somehow from grains to drops. And we have to get from hours to minutes. So I'm going to go ahead and I'm going to change the hours, since that's going to be the simplest part here. So the hours are going to go on top, so they'll cancel out. And 1 hour is 60 minutes. So now we're in grains per minute. We have to get rid of the grains. So I'll put grains on bottom. The problem is, looking at what we have for our information on the label, we have no equivalencies between grains and anything else. So what we have to do is we have to use our knowledge of conversions to convert grains to one of the units that is on the label. And one of our conversions, since we see that milligrams is on the label, is that 1 grain is equal to approximately 60 milligrams. You know, we discussed how that was really like 64, 63 milligrams, but we round with 60 milligrams. So we're going to put 1 grain is 60 milligrams. So now the grains have canceled out, and those are gone. While I'm at it here, I'm going to cross cancel the 60s and get rid of those to make my calculation a little bit easier coming down the line. So right now what we have, if we have all ones here, we're actually looking at 1 milligram per minute is what our flow rate is coming out to be so far. So we are in milligrams per minute. The minutes are okay. We got to get to drops. Well, we have 14 milligrams per 4 milliliters. So I'm going to get rid of milligrams, putting those on bottom, milliliters on top. So 15 milligrams per 4 milliliters. And now the milligrams are gone. Now I purposely left the units off of my drop factor here. I just said a drop factor of 12. But we know the drop factor of 12 means 12 drops per milliliter. So I'm going to go ahead and use that then in my calculation here. Milliliters have to cancel out, so they're going to go on bottom. Drops on top. 12 drops over 1 milliliter. And now my milliliters have canceled out. So this one, things have canceled out pretty nicely. On top, I have 1 times 1 times 1 times 4 times 12 drops. Gives me 48 drops on the top. On bottom, 1 times 1 times 1 times 15 times 1 minute is 15 minutes, which turns out to be 3.2 drops per minute when we divide that out. Now, we don't know if this is with an infuser or if this is going to be done manually. So we'll leave it as a decimal of 3.2 for now. Okay, so to kind of get us back into the mood of these, I want to do one more. Let's do, this time the doctor orders 50,000 units. Boston is out on spring break, but I was expecting Schwamigan, Park Falls.
Okay.
Thanks. Yeah. Yeah, Boston is out for the week, but Park Falls should be in there. Hey, Casey. Not too bad. I'm in the middle of a lecture here, but I can't. Sorry. I'm not free till like 3:30. Or actually, I'll be free at 1:30 if you're around. Okay, see ya. Let's see, we got an order now for 50,000 units over 20 minutes. And the label, I don't know, everything's so small. I'll write a little bit bigger here. Our label now says it's 100,000 units in 1 gram. $250 milligrams in, oh, let's put this down as in 100 milliliters, and a drop factor of 18 drops per milliliter. And I want to know my flow rate here in drops per minute again. So we're going to start out with our 50,000 units in 20 minutes. Now this is already in minutes, so we don't have to change the time. We don't have to change the minutes at all. If I wanted to find my flow rate in like milliliters per hour, then I would have to worry about that. But here we are going to drops per minute. So minutes is what we want in our answer, so we can just leave the minutes in our denominator. We do have to get rid of units. We want to get to drops, but we don't have any direct relationship between units and drops. So we're going to focus on just getting rid of the unit we have until we get to something that'll get us to where we want to go in the drops. So units are going to go on bottom, and what we have here is an equivalency of 100,000 units is equivalent to 1 gram. Now I could have saved myself a step and just replaced 1 gram with 1,000 milligrams, but I'm going to do that conversion here next. 1 gram is 1,000 milligrams, just to show that extra step for you. So what we have right now, the units have canceled out, the grams have canceled out. Right now we are in milligrams over minutes. So we're going to get rid of the milligrams next. And we have milligrams to milliliters, 250 milligrams in 100 milliliters. So the milligrams are gone, and we are now in milliliters per minute. And we have to get rid of milliliters and put the drops on top. And that's our drop factor of 18 drops per 1 milliliter. So milliliters are gone, and we are now in drops over minutes, which is what we want, drops per minute. So I'm going to cancel out some zeros here. I'm going to cancel out these 3 and those 3. I'm going to cancel out these 2 here and these 2 here, so that's just a 1 now. I'm going to cancel out this one and this one, so this is now just a 5 and this is just a 25. And this here is just a 1. So that's enough for now. Let's go ahead and multiply this out. We have 5 times 1 times 1,000 is 5,000, times 1 times 18 is going to be 90,000 drops. On bottom, we've got 20 minutes times 1 times 1 times 25 is going to be 500 minutes. So we divide that out. 90,000 drops divided by 500 minutes is going to give us, what, 180 drops per minute. So we spent a good share of the class on Monday taking that formula forwards like that. So now it's time to look at taking it in the opposite direction. What if we get a problem like this? Let's say that we have an IV bag that contains 1,000 milliliters of fluid. that is set to run at 150 milliliters per hour. How long will it take to drain the bag? And we're going to give the answer here in hours and minutes. So this one is relatively straightforward. We have our 1,000 milliliters is what we're starting with. Put that over 1. And we want to convert milliliters into time. Well, we have this relationship here, 150 milliliters per hour. That implies that 150 milliliters is equivalent to 1 hour of flow. So here, to get rid of milliliters, put milliliters on bottom, and I am going to convert it into hours. 150 milliliters is equivalent to 1 hour. And so the milliliters are gone, and we are now in hours. So 1,000 times 1 is 1,000 hours over 150. And now it's just a matter of dividing that out. That would come out to be 6.67 hours, or 6 2/3 hours. I said to express it in hours and minutes. So that is 6 hours, 2/3 of an hour, times our 60 minutes would give us 40 minutes. So that is 6 hours and 40 minutes worth of time. So that one's not too tough to do, and we're given the flow rate in milliliters per hour, and we need to convert. But if we are given the flow rate, let's say we have an IV bag right today. An IV bag that contains 1,200 milliliters of fluid with a drop factor of 15 drops per milliliter, and it is flowing at a rate of 60 drops per minute. Again, I want to find the time to empty that bag. So again, we are basically working backwards here. We are starting with our volume, 1,200 milliliters, we'll put it over 1. And we're going to try to work to a time. So the first thing I'm going to do is I'm going to get rid of milliliters. What do I have that relates milliliters to anything else? Well, my drop factor is saying 15 drops equals 1 milliliter. So 1 milliliter is 15 drops. So milliliters are gone. Right now I'm in drops. So I need to get rid of the drops. What do I have that's equating drops in? Well, right here I have 60 drops is equivalent to 1 minute worth of flow. So 1 minute is 60 drops. So my drops are gone. So right now we have, the only units we have here is minutes. So this would be finding our time in minutes. So let's go ahead and do that. We have 1,200 times 15 times 1 minute. Should give us 18,000 minutes. 1 times 1 times 60 is just 60. So that's going to give us 300 minutes. So we should now take that 300 minutes and convert it to hours. Most of you are looking at that saying, well, why don't you just divide by 60? And that's exactly what it's going to be. 1 hour is 60 minutes, which comes out to be 5 hours. Normally, we will have, we'll be given milliliters. It is possible that you might be given an order to infuse. Well, let's say we're ordered to infuse 800 milligrams of medication. And you look at the current setup, and it is infusing 40 drops per minute. And you look at the bag, and the bag states, the label on the bag states that we have a drop factor of 10 drops per milliliter, and it is constituted at 25 milligrams in 2 milliliters of fluid. So I need to figure out how long is it going to take to infuse. Find the time. And again, we'll find the time in hours or hours and minutes. So we'll start out again with the volume that we have to infuse. In this case, it's not a volume, it's actually a mass of 800 milligrams. And then we're going to start converting. Now again, we don't have anything that's going to get us from milligrams to time, so we just start looking a way to get rid of the milligrams. We have over here an equivalency between milligrams and milliliters. Milliliters is not where we want to go either, but it gets us away from the milligrams. So that's saying 25 milligrams in 2 milliliters. So the milligrams are now gone. If I wanted to, I could cross-cancel the 25 and the 800 here as well. I'm going to go ahead and do that. So I divide by 25, that's 1. I divide by 25 here, and that should be 32 milligrams. Next, I want to get rid of milliliters. So I'll put milliliters on bottom here. The only thing I have for milliliters is I've got my drop factor. The 10 drops equals 1 milliliter. So my milliliters are gone. And now then I want to get rid of drops. I do have my drops per minute. That is 40 drops. The drops have to go on bottom so that they cancel per 1 minute. So my 1 minute has to go on top. And now I've gotten rid of every unit but minutes. So let's go ahead and find this in minutes. We could go ahead and do the next step to convert to hours, but I like to find it in minutes first because it's easier for me at least to convert from minutes into hours than it is to go from decimal hours into hours and minutes. So let's go ahead and just multiply this out. I'm going to divide out the 10 and the 40 here to get 1 and 4 to make that a little easier. So let's just go ahead with that. We've got 32 times 2 is 64. Times 1 minute, that is 64 minutes. On bottom here, I've got 1 times 4 is 4. So that is 64 minutes over 4. That divides out to be 16 minutes. So it'll take 16 minutes to infuse that medication at that rate. Okay. Let's take a look now at a volume calculator. We're using the same concept, but now we want to look at how much would we actually be infusing. So let's say we have a flow rate of, let's do 125 milliliters per hour. Oh no, how much fluid will infuse in 4 hours? Well, this is actually a relatively simple calculation because we're looking at the 125 milliliters per hour here. if I look at 125 milliliters over 1 hour, to get rid of hours, I can just multiply by my 4 hours worth of time here. Make that a fraction by putting it over 1. The hours cancel out. I just have 125 times 4, which is 500 milliliters. 1 times 1 is 1. So 500 milliliters over 1 are just 500 milliliters. So in that example, over 4 hours at 125 milliliters per hour, we're just going to be infusing 500 milliliters. So let's look at one that's a little bit more complex than that. If we have a flow rate of 12 milliliters per minute, how much fluid will be infused in 6 hours? This one's a little bit more complex. We've got our 12 milliliters per minute, per 1 minute. I have to get rid of minutes first, so we want to keep the fluid, the milliliters, because we're looking for how many milliliters of fluid here. So we're getting rid of minutes here, and it looks like I have to take it to hours. So I'll put in minutes and hours. 1 hour is 60 minutes. So the minutes are gone. And now that I have the hours there, now I can multiply to get rid of the hours by multiplying by my time of 6 hours. I just put it over 1 to make it a fraction. So the hours are gone. On bottom, it's just 1 times 1 times 1 is 1. 12 times 60 times 6 is 4,320 milliliters. So over that 6 hours, we are going to infuse 4,320 milliliters of fluid. Well, let's say we have a setup that is, it's set with a flow rate of, well, let's put in 48 drops per minute. Our label states that we have a drop factor of 20 drops per milliliter. So how much will be infused in 7.5 hours? So we're going to still start with our flow rate. 48 drops in 1 minute. We do have to get rid of minutes. Let's go ahead and do that. We'll get rid of minutes, go into hours. 1 hour is 60 minutes. So the minutes are gone. We're going to have to get rid of hours, and we're also going to have to get rid of drops. Now let's go ahead and get rid of the hours first. I can do 7.5 here. Hours over 1. So my hours are going to be gone. Now I have to get rid of drops. They're on top here, so they have to go on bottom over here. And I have my 20 drops per milliliter, so it's 20 drops in 1 milliliter. Again, that's upside down for the drop factor, but we're going in reverse here. So the drops are gone. We have 48 times 60 times 7.5 times 1 milliliter. 48 times 60 times 7.5. 21,600 milliliters. 1 times 1 times 1 times 20 is 20. So we divide that out. The 21,600 divided by 20 is 1,080 milliliters. So over that 7.5 hours, there will be 1,080 milliliters of fluid infused into that patient. So you can see these formulas are going to be going both forward and backwards. Okay, so enough for flow rates for now. Actually, I do want to do one more example. I want to look at, oops, we have an IV, contains 2,000 milliliters of solution. It was started at 7 a.m. and ran until 9 a.m., which is when you started the shift. So you're coming in at 9 a.m. and you are seeing this is a 2,000 milliliter bag that was started at 7 a.m. And right now, you are seeing that the bag contains 1,400 milliliters of fluid. And it is set to infuse at 40 drops per minute. You want to figure out what is the drop factor here. So to find the drop factor, we've got to get to an equivalency. Remember, drop factor is in drops per milliliter. So we need to get to drops per milliliter somehow. First thing I am going to do is I am going to figure out how much we have infused. It started at 7 a.m. with 2,000 milliliters. At 9 a.m., it was at 1,400 milliliters. What that gives us is, by subtracting there, that we infused 600 milliliters over from 7 to 9 is 2 hours, over 2 hours. 600 milliliters over 2 hours. So I'm going to start with that rate, 600 milliliters over 2 hours. We're going to see where it takes us. I do have the 40 drops per minute. So I'm going to convert hours here into minutes. 1 hour is 60 minutes. And what that's going to do for me here, the hours are gone. I'm going to cross cancel here 60 and 600, both divided by 60, so that'll give me 10 and 1. So I've got 10 milliliters here in 2 times 1 minute is 2 minutes. I'm going to divide that out. 10 divided by 2 is giving me 5 milliliters in 1 minute. I just did that to make it a little simpler for me here. So we are flowing at a rate of 5 milliliters per minute. I have this drop factor here of 40, or not drop factor, this flow rate of 40 drops per minute. And I have this flow rate here of 5 milliliters per 1 minute. They have to be equivalent somehow. Well, I need to have, remember, a drop factor, as we said, is in drops per milliliter. So I need my drops to be on top. And what I need to do is I need to figure out which one of these I'm starting with and which one I'm going to use as the conversion. And since I need my drops to be on top in my answer, I'm going to start out with this flow rate that has drops on top already. So my 40 drops per minute. And now I'm going to use this other flow rate to convert minutes into milliliters. So minutes have to go on top, so they'll cancel. Milliliters on bottom. 1 minute is equivalent to 5 milliliters of flow. The minutes cancel out. 40 drops times 1 is 40 drops. 1 times 5 milliliters is 5 milliliters. And that divides out. 40 divided by 5 is 8. That unit would be drops per milliliter. So that's a rather thick fluid. Any questions on any of those examples? Okay. So a little foreshadowing then to Friday's class. We're going to be starting to look at dosages based on weight and body surface area. Body surface area, a lot of times there's dosages calculated for burn victims, for pain and for other things, for nerve blockers, and also for certain skin conditions that can be based on body surface area as well. Basically what we're looking at is rather than the doctor prescribing the total dose to give, they're just telling you to give the recommended dose off of what the recommendations are for that package or for that medication. So that's one thing is that we can get out of these is to find the dosage. So calculate the dose to actually administer to the patient. The other thing we can do is we can check for a safe dose. So we're checking the doctor's orders for a safe dose. Even if you're working as an RN or medical assistant or whatever, if a doctor prescribes a dose, you are still responsible to double check it to make sure it is a safe dosage. So taking what the doctor has ordered, a certain number of milligrams, and double checking it with the label that may say 2 milligrams per kilogram or whatever. So we're going to start out talking about dosages based on weight. And to deal with dosages based on weight, we have to first convert all of our weights into kilograms. A dosage based on weight might look like this. 3 milligrams per kilogram per 8 hours. So what this is saying is every 8 hours, this patient can receive up to 3 milligrams per kilogram of body weight. So if there is a patient that weighs in at 154 pounds, obviously pounds does not fit on that recommendation there. So first thing we have to do is convert our 154 pounds into kilograms. So you put 154 pounds over 1. The relationship between pounds and kilograms, and this is one that's going to come up enough in the next couple weeks. You should have it memorized. We're getting rid of pounds. They're on top, so we're going to put them on bottom so they cancel out. 1 kilogram equals 2.2 pounds. Now, some textbooks say 2.208, some say 2.21. For our purposes, it is close enough. It's exact enough to just use 2.2. And that is a standard in the medical fields, by the way, is just use the 2.2. So the pounds cancel out. 154 times 1 kilogram is 154 kilograms. 1 times 2.2 is 2.2. So 154 divided by 2.2 is 70 kilograms. Now this calculation right here, going from pounds into kilograms, happens enough for us when dealing with dosage and dealing with patients, that rather than filling out this conversion every time, making it a fraction and multiplying by a conversion factor, we are going to go ahead and just say you take your weight in pounds, divide it by 2.2 to get their mass in kilograms. Now that we have the 70 kilograms, this factor up here, this recommendation up here, safe dosage, has several relationships implied to it. So 3 milligrams is related to 8 hours. The kilograms are related to 8 hours, but that's not such a big deal. The 3 milligrams is also related to 1 kilogram. Think of that as being 1 there. So we have that equivalency from this recommendation here of 3 milligrams will be equivalent to 1 kilogram of body mass. So we can take our 70 kilogram patient here, put it over 1, and we can use our unit conversions. 1 kilogram is equivalent to 3 milligrams. So the milligrams cross cancel out. On bottom we have 1 times 1. On top, 70 times 3 milligrams is 210 milligrams. Now we can't just forget about this 8 hours up here. We do have to bring that down. This is saying that we can administer to this patient 210 milligrams of that medication every 8 hours. Now what I did here was I was trying to stay consistent using this dimensional analysis to convert from the mass or the weight of the patient to the dosage. I had mentioned before spring break, before our week off here, that when I'm doing dosage calculations, you can do everything with that dimensional analysis, with that unit conversion. But I often use a mixture of that dimensional analysis and a proportion. This is actually one spot where I would most likely use a proportion. We have that relationship of 3 milligrams per kilogram, so per 1 kilogram. And I would most likely set it up, okay, 3 milligrams per 1 kilogram. How many milligrams then per 70 kilograms? Then we'd cross, multiply, and divide. 3 times 70 is 210, divided by the 1 kilogram, divides out the kilograms. So it's 210 milligrams. Okay, let's do one more example of that, and then we'll call her a day. So we're looking at the label on the bottle, and it tells us 0.8 milligrams per kilogram per hour. We are also looking at a patient who comes in with a weight of 88, I don't want to put kilograms, 88 pounds, I should say. 88 pounds. Well, my first step, I'm going to take that 88 pounds, divide it by 2.2, give me 40 kilograms. So that 40 kilograms then will be used to calculate my dosage based on their weight. I could use the proportion or I could use unit conversions. To me, like I said, it just makes more sense to use the conversion or the proportion here. We have 0.8 milligrams per 1 kilogram. How much will that be for 40 kilograms? We'll cross multiply. 0.8 times 40 is 32, divided by 1 is 32. So that is 32 milligrams. Now, as I said, we could have done the 40 kilograms and then converted that using a dimensional analysis. Putting kilograms on bottom, milligrams on top. 0.8 milligrams is equivalent to 1 kilogram. And we're going to get to the 32 either way. The time when this might be simpler to use the dimensional analysis rather than the proportion would be if there's additional steps. And let me show you what I mean by that. Let's say the bottle, the label states for a liquid medication, for a liquid drug, that you can allow 1.2 milligrams per kilogram per hour, and that it is constituted at 20 milligrams in 5 milliliters. And you have a patient coming in at 132 pounds. So again, I'm going to start out with that 132 pounds and divide by 2.2. Should give us 60 kilograms. So our patient's 60 kilograms. I could use the proportion to find out how many milligrams of medication here. And then I would have to take that amount and I'd have to convert it with this equivalency here. So let's go ahead and do that. 1.2 milligrams per 1 kilogram. How much is that for 60 kilograms? If I cross multiply and divide, 1.2 times 60 divided by 1, it is 72 milligrams. But now this is a liquid drug, which means it's going to be administered in milliliters. So I take my 72 milligrams over 1, and I am going to convert milligrams to milliliters. 20 milligrams in 5 milliliters. Crossing off my milligrams, this gives me 360 milliliters in over 20, which divides out to be 18 milliliters is what we'd administer to the patient. As I mentioned, that might be one spot where it would be simpler to start out with just the 60 kilograms, put it over 1. You could do 1 kilogram is equivalent to 1.2 milligrams, getting rid of the kilograms, and then adding the next step of 20 milligrams and 5 milliliters, so the milligrams cancel out, coming up with that exact same answer, 360 over 20, which is 18 milliliters to administer to the patient. So whatever method at this point you would use to get to that, I'm okay with that, just as long as you are sure of it and you can get there every time. Okay, we will start out next time with these dosages based on weight again, talking about them a little bit more. So for right now, I'm not going to give you any new homework based on the weights. I'm just going to have you continue the homework that we talked about last time, which is mostly page 178 and 179, those problems 1 through 21, the odds. Still on IV flow rates. Pay particular attention to the ones that work backwards, the ones where you have to find the time to infuse or to find the volume infused. Those are the ones that people tend to struggle with on the test. Okay, you guys have a great day. We'll see you on Friday.